Hi there, I'm John from CNCKing.com, and today we're going to show you how we make these custom stainless steel plaques fiber etched. When I first started CNCKing.com almost 8 or 9 years ago, the first thing I realized is that if I'm going to start a company doing serious industrial work, I need a laser that can have both a fiber and a CO2 laser source. The CO2 is great for everything but metal, and the fiber is the opposite. It's great for metal and sucks for everything else, basically, other than polycarbonate. We do some color changing on that using the fiber laser source. Now, the nice thing about this kind of work here is that we have, this is 10 gauge stainless steel, 304 with a brush finish. It might be hard to see in the video, but there's a nice brush going all the way across it. And it really helps to make the aesthetics really wonderful on this kind of work. The reason why we use a fiber laser source instead of our CO2, because we do have both options, and the CO2 is dramatically faster to do this kind of work than the fiber. The problem is the CO2 with the ceramic paste comes off, peels, fades, cracks. It's just horrible. At first impression, it looks really, really nice, but then it starts to degrade rather quickly, especially if it's outdoors. For this here, we use our fiber laser source, which is a very permanent process. It will not fade, crack, peel, or come off, ever. And actually, the heat from the laser is actually tempering the steel, which gives it a bit of the color. So what that means is, where I fiber laser etch, like here, you can see definitely here, if anything wears out, it's anything other than that first. So it just gives you an idea. I have some keychains that I made for years ago, and I keep them in my pocket and all that kind of stuff. And they've never worn out, they've never faded, cracked, or anything. It's a very nice process. It's a very slow process, but it's definitely worth it if you have something that outdoors and you want to have it for a very long time. Because fiber laser etching is such a very slow process, this is incredibly sped up. It takes a long time to do, and when the fiber laser source is going, or the gantry head is going over an area with no etching, it still counts as etching. It doesn't skip through to just where the etching is. Now for a plaque like this, you'll see the names going all the way down. So what I did is I changed the laser so that instead of going left to right, it's going up to down, as you can see here. I just have the angle of the camera on the head of the laser, on top of the laser cabinetry, so you can see what is happening here. The green light that you see here is actually when the fiber laser etching is happening, and when you see nothing, the gantry is still moving the same speed. There's just nothing's being produced because there's no etching at that specific area. What I always find amazing about this process is how accurate our machine is, because you're going over a plaque that's basically almost 40 inches by 26 inches, and everything is nice and sharp. You don't have anything sort of dodged or moved over or shifted or any of that kind of problem. The metal itself is probably around 35 to 40 pounds, so it's definitely not light. So it's a little bit tricky getting it into the machine because you don't want to dump something this big on a machine that's so fragile with optics working on it. So once the fiber laser etching is finished, what happens is that I gotta let the plate cool down because it's a very hot process. It's not as hot as if I was plasma cutting this thing. That's molten hot after it's done production, but it is definitely hot. I also have a lot of air shooting down from the gantry head onto the plaque to cool it down during production, because the last thing I want to do is have this thing warp. And I also have the exhaust system sucking air out of the machine at the same time. Again, to suck all the hot air out, but it's still really hot after the process, especially on something this large. Now it's a little bit tricky on something this large because I have to be I have to keep in mind that I have a very tight tolerance to deal with, and if the metal starts to warp too much, what you end up having is not etching, but annealing or nothing at all. So it's a very finicky process in that way. Now, as this is not a stencil, though technically we can make this into a stencil if you really wanted to, we don't really have any limitations when it comes to font size and the font type and that kind of stuff. If we're doing this as a stencil, like this here would have to be cut in half with the support material to make sure it's still there. So that's the only real difference. And when it comes to imagery on this, any vector image works great. And everything is nice and sharp as well. Because again, we're not cutting all the way through the plate metal, we're just etching and tempering the top surface of it. Now you might wonder why there's no fingerprints on this. That's because after I do the fiber laser work, I do a lot of cleanup on this afterwards to clean up any spots. It's not really dirt that builds up, it's more of like It's like when you do welding, you have those little pieces of dark lint, almost like that. And that's what you end up having on this. So I clean that up and it gives you a very nice clean surface to work from. You could technically eat off this too. We do a lot of custom work for the food industry and industrial food production. And a lot of the control panels and that kind of stuff, we use exactly the same processes here because they can do washdowns and not have to worry about anything coming off, fading, cracking, or peeling, and so forth. Now, we did do a massive job almost a year ago now that I haven't really told anybody about, other than those that need to know, where we did a lot of fiber etching exactly like this. It was basically a massive vault that we created, around 3,000 pounds. And because of the size of the vault, we couldn't fit all the pieces inside of our machine. So similar to what we did with this sign here, we split it up into 2 pieces or 3 pieces. In this case, it's 2 pieces. And then what the customer would do is put it together on site and do the bolting. But for the vault that we created a while ago, we actually had to have it all welded onto it. So it looks like one continuous sheet, basically. You still know that it's tiled, but you have one continuous image going across the whole thing. And that's just really, really cool. Now you'll notice here that it's a lot larger, the font, and that's an area I gotta be very, very careful about, because the more black that you see, the hotter the metal will get, because the more fiber etching is happening at that specific area. What I've done before is, if the plate really starts to warp, and I've had that happen before on something a lot more dense than this project here, I actually have to pause the machine, cool down the plate a little bit, and then let the machine keep going. The problem is, when you cool it down, if it's a little bit too hot, it warped a little bit, and then when it cools down, it goes back to its normal flatness, so to speak, and then you might have a space. So it's a little bit tricky to do those kind of projects that we do here in the shop. I haven't really shown anybody on their video or blog me doing those kind of jobs because they're almost all NDA based and we can't show people, but you know, a job like this gives you an idea of the kind of work that we can do. Now, we're not limited to just flat plates as well. As mentioned, we can also bend this after the fiber etching process. So you're not limited to just flat plaques with us. Anything sort of works with us, as long as whatever you want. We can also cut out holes in this too. So let's say the Dobson field on the top there, if you actually wanted that cut out as part of the plaque, we could have done that just as easily as everything else that you see here in the shop. So what are the limitations when it comes to doing this kind of work specifically? The biggest limitation is really time. This takes, a day, 2 days. So you're looking at 2 days of work with a fiber laser source. And that's a lot of time. It's very finicky as well. We have a very tight margin to be able to produce the result that you see here that's consistent. So it's very important that the stainless steel itself is totally flat. If we have a piece of stainless steel that's bowed like this process will absolutely not work for it. And that's why you might see using ceramic or other sort of processes to do it. That being said, if you want this rounded, what we generally do with our customers is we do the fiber laser etching first, as you can see here. And then what we can do is roll it so that it can be a round thing that's fiber etched. We just can't do it on the round thing beforehand. So start with a flat plate, do the etching, and then bend it. That's totally fine. And again, we're not adding anything to the metal as you see here. So when we bend it, there's nothing that's going to crack or peel or fade or anything. It's just part of the metal itself. So if you're looking for custom fiber laser etching work, contact me at CNCKing.com. We can make both the plates and the fiber etching and ship it right to your door.